Welcome everybody to this first talk organized by the project Fit for Reuse. The multi-stakeholder platform on which we are hosting this initiative has been realized to foster knowledge exchange through a participatory approach aimed at promoting the involvement of the different actors in the water use community. This aim, this first talk that will be active in the next weeks, is dedicated to the Horizon 2020 Innovation Action Project HYDROUSA. Today we have with us the project coordinator, Professor Simos Malamis from the National Technical University of Athens. First of all, thank you very much, Professor Malamis, for being here. So, could you share with us how is HYDROUSA tackling the issue of water scarcity and how the project outcomes can be transferred to other territorial contexts?
Thank you, Viola, for the invitation and for the welcome. And so I'll try in 15 minutes, more or less, to give you a brief overview of what we do in the HYDROUSA project. The project now is in its 4th year of implementation, so we have a lot of things we've already done, and I can share with you the findings of the project. But before that, I would like to start to show how this project fits with EU legislation and how it supports it. Within the recent Urban Wastewater Treatment Directive evaluation, which took place a couple of years ago, individual or other appropriate systems, as well as small agglomerations, were found to have a critical load, that is in terms of organic matter, nutrients, and coliforms that are currently being discharged into our water bodies and could be avoided. And these are actually circled here in this histogram. And these are exactly the loads in which HYDROUSA project is targeting in order not only to eliminate, but also to recover valuable resources from the reclaimed water. So if I were to present you HYDROUSA in one picture, this is it. This shows the totality of the solutions we have developed and are currently operating within the project. So we have wastewater management loops in which we treat domestic sewage with anaerobic processes, the high rate UASB process, coupled with constructed wetlands to treat wastewater and deliver rich nutrients and with no pathogens, liquid, that is a liquid fertilizer for agriculture that is valorized in agriculture. We have rainwater harvesting solutions from the rooftops, but also from a subsurface system that we valorize rainwater, but also stormwater for domestic applications, but also for agricultural irrigation. We have seawater desalination system that is based on the mangrove plants, and it's a technology that uses solar power in order to evaporate and condensate water, producing fresh water. All of these solutions are demonstrated in 3 Greek islands in the Mediterranean region, which is the focus of this project. So I'll give an overview, a very fast overview of each of the 6 demonstration sites that we have. Demonstration site 1 is in Lesbos Island. It's a completely circular, decentralized scheme for wastewater treatment and use of the reclaimed water in an agroforestry system. An agroforestry is a system that combines agricultural trees together with annual crops. Is a diversified agricultural production system. We couple anaerobic processes with a nature-based solution of a vertical flow constructed wetland. You can see here some pictures of the anaerobic processes of the wetlands. At the bottom, it's the fully developed wetlands, which have been developed, and we're also testing some high-rate electroactive wetlands at pilot scale. Here you see some of the cultivations that are ongoing. We have a wide variety of crops which we use reclaimed water to grow, and we are currently harvesting. Again, here you can see it was a completely remote field that was revitalized through the HYDROUSA project, resulting in different cultivations. Also here you can see the constructed wetlands. In Hydro 3 is a remote rainwater harvesting system consisting of zero energy collection system of rainwater storage and use in agriculture. In Hydro 4, it's a residential rainwater harvesting system where we recover rainwater, we treat it through a slow sand filtration process, and we also recover stormwater through a bioswale process, and we store it during the wet season into the aquifer to use it during the dry season when the water needs are much bigger. In Tinos Island, we implement a seawater desalination system. You can see a top view on the bottom left, where we use the mangrove still technology to recover fresh water that is used in order to cultivate a tropical plant greenhouse. And finally, in the sixth demonstration site, we have a remote ecotourist facility known as the Tinos Ecolodge facility, where they are completely circular and developing completely circular solutions in terms of water recovery and energy. They have they are an off-grid system, so they use all the energy they use is from photovoltaic panels, and they use the recovered water, rainwater, vapor water, and treated wastewater for their cultivations, which they use to nourish their the customers, but also they give to local restaurants. The project supports a lot the EU policy. We have developed two policy briefs, one on how the project supports the European Green Deal, and the other one on the evaluation of the Urban Wastewater Treatment Directive, focusing on the challenge of individual or appropriate systems. We also have a very nice publication on the policy and legislative barriers related to small and decentralized water and wastewater systems. We have developed a new framework for assessing circularity, which is currently used by a big water industries in the field. And we also have a couple of interesting publications that are relevant to the EU policy. A major finding of the project has been the fact that we are able to demonstrate that we can produce Class A agricultural irrigation water without the need for the filtration process. So the anaerobic process, together with constructed wetland and disinfection, is able to deliver the required quality without the need for an additional filtration step, which is actually required within the water reuse standards of the EU in order to achieve Class A agricultural irrigation water. HYDROUSA has been acknowledged by two very prestigious awards. We have received the Mediterranean Climate Change Adaptation Award, as well as the Prima WEF and Nexus Award by the Prima Foundation. We have worked from very early in the project on how we address the existing policy and the regulation. So for each water loop, we have done a fitness check and trying to identify barriers and opportunities related to the existing legislation. And where there are barriers, we need to see how our solutions could address it in order to find the market prospects. And of course, in our business plan, we also address apart from the regulation, the economic aspect, the payback time of our solutions, which is a very, very important issue. And we have worked a lot on the transferability of our solutions to other areas. Within HYDROUSA, we are testing 25 transferability case studies within Europe, within the Mediterranean and beyond. And one of very, very successful case study, a transferability case study, has been the Gorgona Island in Italy, where the consortium worked very hard from the beginning. We do a methodology, specific methodology was applied actually in all case studies relating to the social part, environmental, technical and economic analysis of our solutions in the specific area. There was a long consultation period with the relevant stakeholders in the Gorgona Island, and this also involved the local people and the inmates of a prison that is located in the island. And the result has been that this work is actually funded and will be delivered in Gorgona Island, and is funded by national money of within Italy. We are working with stakeholders from the very beginning of the project, and we have built an active community, an active water community, and we have actually co-created solutions together with the local stakeholders. So, for example, the agroforestry system we developed in Lesbos Island, the selection of the species was based on the input of locals, and as well as an ethnobotanical study that was done. And actually the locals, that they know what to grow in their land, had a major say on what species to grow. Also, the water monitoring, the low-cost water monitoring solution we developed was based on people's opinion on what parameters to actually measure. Also, in terms of the replication of our solutions, several of the HYDROUSA solutions are currently being retrofitted and implemented in other projects, including the Fit for Reuse project, where we are testing the electroactive constructed wetland, but also other projects like the industrial Axel Water Horizon 2020 project and water mining, but also national calls such as Circ for Food and Eridiri. And this has been very important for us, because we are actually testing our solutions in different environments, but also in cases such as the industry, which did not initially envisage within HYDROUSA project. The multi-stakeholder, the multi-sectoral water circularity assessment tool is a very important and strong tool that considers the water, energy, food nexus, and it tries to assess our solutions through a circular approach. And this methodology can be applied and extended in other areas and in other cases. And Jacobs Water is actually using this tool, this methodology, in order to in tenders that they are putting in bids, in order to assess their circularity. We have a low-cost irrigation scheduling tool product, which is on the market and it's currently selling. This is also a major finding, or a major, let's say, achievement of the project, which we are quite proud of. So thank you very much. That's all from me. And there is also, after this presentation, a follow-up on questions and important material that we will share, and you can get to know more about what we've done and what we intend to do within the project. Thank you.
Thank you very much, Professor Malamis, for this really interesting overview of the project, and also for sharing some project material that are now available on the multi-stakeholder platform. It was really a pleasure to have you here today, so thank you again.
Thank you very much for the invitation. It was my pleasure.